So we looked at, there we go. We were starting to grade homework number 2 and 4 and 10. Dun, 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 dun. And then we were talking about how to plug it in. So then, guys, what was the very first thing that you solved for? After you plugged in for T is 10, A is this, P is this. Who's missing? R. So hopefully you used ln like this probably showed. To find our question, why didn't they just, oh, they did. They put it in a nice little decimal, changed the nice little decimal to a nice little percent, especially people gone yesterday. You should be super focused because we have a test tomorrow. So then the final answer is 11.0%. Why the 0.0? Because I bet there were more decimals. Luca.
I kept it in the ln form just because I know I would plug in e to the power of ln or something.
No, you're totally good. But this is, remember you're supposed to fill in a blank for rate? So for filling in the blank for rate in the chart, you need to round it. So this is the answer for rate. But you're right. Yesterday I did the same thing in class, didn't I, guys? Hannah, focus. Yesterday in class, I said, why don't you plug in the perfect form for R? Now, they plugged in the decimal form. They got a little bit of error. I don't like their answer as much as I would have if you had just plugged in the whole thing. So, Luca, I agree. I would have kept that whole thing and plugged them in for R in this one, and then it would have been perfect. Yeah, so no, I agree with what you did. Okay, let's keep going. Number 24. Now, wait a minute. Hold on. My people here yesterday, did we talk about... There are too many windows open. Hold on. This is confusing me. I don't need him. Go away. Nope. I probably need him. I can get rid of him. Okay. Didn't we also go over one of the ones from this section? Yeah. So what formula were we using in this section? Look at him right here. Why were we using this one? Says decay. And this is the formula for, Issa, you focus, bud? Even though it's his birthday, you gotta focus. This is the formula for exponential decay, right? Now, the nice thing is, for those of you guys that were gone yesterday, we drew little arrows to show what everything was. This is amount after, wait, isn't this formula an awful lot like this formula? You have something here that means amount after time. You have something here that means the beginning amount. This means time. This means rate. What's over here? This one means amount after time. Oh. This one means the beginning amount. Oh. This one means time. So, you don't have to get super confused even though the situation changed to be radioactive decay instead of money. When they gave you a number 24, who is that? PU? Is that polonium? When they give you, they didn't give you initial quantity. That would have been nice. What did they give you? Yeah. So wait, T is 1,000 for this, right? T is 1,000, and what would the 0.4 be plugged in for? I have a T is 1,000. 0.4 would be for the Y. Huh. Well, I'm missing the A and I'm missing the B, right? Yeah. Okay, so what's going on with the half-lifey one? Why am I doing this all together? Well, I started to show you the answer, and everyone was like, I didn't know how to do it. Well, then having you write down an answer you don't understand doesn't help, does it? So let's go ahead and take this formula. Let's take number 24. It'll be in blue. Let's separate it off from that one. So we can go ahead and say, all right, so we know 0.4 is how much is left. Oh, I don't know the initial. I know there's supposed to be an E. I don't know him, but I know 1,000 years. Okay. What does the other clue tell me?
That half of the initial, it takes 24,100 years for it to decay to that point.
Takes 24,100 years, not to decay to zero, decay to half of what it was to begin with. So if this was what it was to begin with, what's the new amount? 1/2 of him.
But then we can say that the 24,100 times 2, then your A is going to be 0.
Not 0.
No.
Your A is going to be 1.
Yeah. So it'll be half, and then we can natural log. Throw that natural log in there.
So the first, I started using that clue first, and he didn't really get me anywhere, but this clue, oh man, I see B and I can solve for it. So if it tells me half-life, and yesterday when we were doing this one, guys, and I wrote this clue, I was referring to money because it was a lot like the money one. If I was to actually write it, I would say y is equal to 1/2 of a. Whatever you had to begin with, he's been cut in half. So whatever we had to begin with, he was cut in half. And when you divide by a, you just get a half. And then Sean, you're saying throw that ln in like we did yesterday. Ln and e cancel. B is equal to -1/24,100 times ln of 1/2. Now I'm going to go back to the answer key. But once we have b, which we do now, can't I take b and can't I plug it in, plug it in? Why is that good? Who's the only variable who's going to be missing after we plug in a number for b? Just a. So we're going to take the 0.4, we're going to divide by all of that mess that we can put it all in our calculator, and then we'll have who a is, and we're done. Does that make sense? So let's go see what happens after we go ahead and solve. B ends up equaling da-da-da-da-da-da. Oh, hey, that's what we got. And Luca, if you notice, they didn't even decimal this one just because there wasn't in the table. There's not a place to plug them in. I think that's why they didn't. And they left them all nice and precise. They put them in the B spot. And just like we said, A is the only one alone. Divide that whole thing over in your calculator. You should have ended up with 0.41 gram. 0.41 gram. Okay, you guys have that one written down?
So no matter what, we have to get the rate first.
Usually. But you're just plugging in clues and seeing who's missing that you can solve for. Does that make sense? For the money and for this one. Woo! Let's come back to number 30. 34. Now let's go to number 34. We'll come back to 30. 34. Why are you using this formula? Did they give it to you, or did they say growth, or did they say both? Both? Okay, they gave you the equation and they said growth. After 1 hour, t is 1, so they plugged in 1 for t. After 10 hours, t is 10, so they plugged in for 10. And then they said the population after 10 hours is 2 times the population after 1 hour, or is double. So that's how they used the clue. They said, hey, after 10 hours it's double. I might have done it a little differently than that. But technically that does work. That does work. So they plugged in the 1, they said, I don't have enough to solve. They plugged in the 10, I don't have enough to solve. Then they said, take the clue, the population after 10, which is him. He is 2 times this a 1. So they just set it up as an equation. He is 2 times that a 1. After 10 hours, the population is double what it was after 1. And then all they have now is just a solving game. It was a little tricky because you had exponential pieces on either side, right? But we can deal with that because we can divide. And when you divide, which might have been a little tricky, this in-between step, e to the 10b over e to the b equals 2. How do we put these together? Dividing like bases, you subtract the powers. So 10b minus 1b is 9b. ln both sides, get that e out of there, divide by 9, dun, 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 for the b. And then we plug in the b and they say, hey, now time is 6. So now all we have to do is plug in 6 and then use our nifty-difty calculator to solve. Final answer, 397 bacteria. 397. Number 48. Was he the frequency? Was that one? They gave you, here he is. Do you see the model they gave you? And they gave you the, what did I, oh, the intensity, is that what it was? What does I stand for? Oh, what happened to writing down problems? How'd that go? Real good, huh? Alright, well I'll just be looking really carefully to take off points, that's a bummer. Because now we're wasting time. Okay, I is intensity, like it said in the big paragraph up above. If you guys were totally lost, you might not have read this that told you all of how to do it. Okay, so then coming back, that nice little paragraph gave you that nice little equation. It said that I sub naught is the intensity of. They literally just gave you that number, so we were able to plug in 10 to the negative 12 for all of the little I sub naughts in our little formula. They just said, do that. And we said, okay, fine, whatever you say. And then they said, find the level of B for each of the following. Kiddos, here's the crazy part. Literally,
So all my numbers are different.
uh-oh, did you do number 47?
Oh boy.
Okay. Here's the crazy thing with number 48. They told you this formula, they told you this number, and they gave you new numbers for that. And they said, plug in, okay, plug in, okay, plug in, okay, plug in, okay. All you have to do is plug it into your calculator. So,
Cool.
there was no crazy solving for anybody. It was literally, they told you who to put in the I spot. So you put it in, and guess what? That can go in your calculator, got it. That can go in your calculator, got it. That can go in your calculator, and that.
Why doesn't it become like in C? Why is it not 18? Because
18, remember
Oh,
the
it's
power
because it was
comes
like
down
80.
and times. Multiply.
it's like it was 80 before.
Yeah, multiply. And then number 52, you guys can already see the final answer is 4.95. That one was very similar. If you read the directions, the paragraph before, and I think it might have been, there were lots of those PH ones kind of in a row. You had to go back just a little bit. The paragraph gave you this formula, and it gave you for this one the number to plug in. Solve. It was just having you deal with, hey, can you take harder words and harder symbols and still just know, plug it in, done. That's what was hard. So some of you didn't look at the paragraphs before, so you didn't even see the formulas. And you didn't realize because you just got all confused. All you were doing was plugging in. Can you take a variable, have a number for him, and plug him in and just solve with your calculator? That's all that was going on in these last ones. Number 66, oh, sorry, that's really tiny. Can he get bigger? There we go. There. I think 66, didn't they give you graphs and just say, hey, what's it look like? Okay, so on these ones, you guys should have gone to your notes, you should have looked at the graphs. Logarithmic, remember, he's going to be the one that's going to look like this, kind of. He's going to slowly increase. Logistic, he's going to have the go really fast and then level off. Exponential, rapidly decreases. Ooh, that must be that one. He's been flipped, but that's still an exponential. Because remember, normal exponentials go like this, and this one just got flipped horizontally, so he's decreasing really fast. Linear, hopefully you guys got that one. Uh-oh. Letter E was the funny one, because it said none of the ones given, because it seems to be a combination. It had a linear piece and a parabola piece, or a parabolic piece. So E was the tricky one, he was none. F was exponential, because he rapidly increases. Quadratic, because there's a parabola. And then Gaussian, ooh, what was that one? He was the funny bell-shaped one that you don't need to memorize for the test. And who else don't you need to memorize for the test?
Logistic.
The nasty one. Oh, yeah, ooh. Sound good? Number 30. Was he a bit of a beast?
Yeah.
But you were just plugging and chugging. But there was a lot of plugging and chugging. I'm not going to go through every single country how to do it. Look at this.
He was the cause for me to email you.
Oh, was he? That makes sense. Oh, wait. Where's 30? There he is. Now, remember the book? They show everything. Hold on. Calm. For every country, how much information did they give you? 2 facts. 2 different times and 2 different populations at those times. Okay? 2 different times and 2 different populations at those times. And they told you to use exponential growth decay. It depends on whether it was going down or going up as to what formula you would use. Technically, you could just use the growth formula, and if it was decay, B would end up being a negative number. Either way works. So what you need to do? Plug in the time for T as to what year it was. Plug in the population for Y as to how many people there were. Do it for both points, and then do a little substitution. because you have two variables that are missing. We can't work with that, but we can go ahead and solve for A and then plug it in for A of the other one. Then we solve, and we end up with a proper equation of, what does B equal? They just did a nice little decimal so they didn't have to worry about it. And then with that nice little decimal, then they went ahead and were able to plug in and solve for A. And then with A and with B, they said, hey, with these two facts, I can tell you an approximate model for how the population is changing in Bulgaria, so that in 2030 we can predict how many people there will now be. Which, if you notice, doesn't seem to be a very good thing because their population is decaying, right? Now some of you would say maybe 2 points of data isn't enough to necessarily say this is a great model, and maybe it's not, but that is one way to predict how many people they will have. So Bulgaria predicted to have 6.1 million people in 2030. Canada predicted to have 39.2 million people in 2030. Who is next? China predicted to have 1,441.1 million people in 2030. Crazy, huh? United Kingdom, 69.5 million people.
It didn't in the test, I'll cry. I'll start crying.
United States, 375.8 million people. And basically B and C were just concept-y questions. The faster it's growing, the higher B will be, and whether B is positive or negative shows whether or not growing or decreasing. Some of you are too stuck on the math and not stuck on the numbers. The numbers were pretty crazy that we just looked at. Anyway, that's why I wanted you to do the problems. I thought was very interesting just in terms of getting a perspective on the world, but maybe some of us lost that point. And I do admit the math was a little scary. All right. There's no way a number 30 is on the test tomorrow. How? I'm not going to give you one problem and make it 100 or 0 if you get it or don't, right? That's ridiculous. And I'm not going to give you a problem that takes literally quite a few minutes to complete. However, we do need to talk about what is on the test tomorrow. So, kiddos, you had last night the objective of attempting 3.5 as much as possible. You had about half a workday yesterday to work on 3.5. Maybe even some of you guys got working in class on the test review. But my encouragement was that you guys start on or get through the test review last night. Question. The entire test going to be word problems from 3.5. No. Where have we been this chapter, cool kids?
Everywhere.
Yeah. Where did we start off with? What was in section 1? Yeah, we just talked about exponential functions, and we talked about how to plug them into our calculators. What? That's lame. How to think about their graphs and what they're going to look like when they get transformed. So, question. If you want, you might want to turn in your notes and highlight a few things of what I say might be important for tomorrow. Good idea. Go team. Isn't it easy to mix up transformations? So I would say we might want to just look over the graphs of exponentials and logarithmics, the transformations. So I put a quick little highlighting on the exponential function graphing. We did a couple examples in our notes, but homework had more examples. So I don't know if you want to memorize these examples. That's not a good idea. But you do want to review what transformations are going on when numbers get added or subtracted on the inside, on the outside, etc. That's a good thing to highlight. And along with that, the graph characteristics, not to memorize, just to understand. Exponential has a horizontal asymptote, things like that. But then we even had ones that were as easy as, remember the one-to-one property? Wasn't he fun times? But he could be tricky, right? So the one-to-one property, he's fun times for exponential and for logarithmic, but sometimes you have to factor. Sometimes you have to factor, so just be ready for that. And then e's, they don't scare us, but if we have a quadratic, remember, move everything to one side, get equal to 0, and factor and solve, right? Okay, we went to logarithms.
Not extraneous.
Yeah, but extraneous is only really a problem for logarithms. Exponential we'll never have to worry about. But yeah, check it's not extraneous. We'll get there with the domain problem. Logarithms. Hopefully you guys know by now, right? The difference between ln and log with nothing versus logarithms with bases, right? Not really much to highlight there. I would say a good highlight would be to go from logarithmic to exponential. I think you guys understand how to do this with the inverse property. Big ol' a to the a to the y equals x. But some of you might want to still have this property memorized, how to go back and forth. Change a base formula. Ooh, he's a good one. How to go from a log base 2 to like a log base 3. Remember, it's argument over base, the old base. People with the yellow button in your calculator, there's going to be at least part of the test that's calculator. I think tomorrow is going to be our official first part non-calculator, part calculator, especially those word problems. There's no way I'd make you do those without a calculator. So make sure you can use your calculator, but also make sure you can do things without when it wasn't needed in homework and when we didn't use it in class. Like with the change of base. What's one of these that you guys commonly forget? Any log of 1 is 0. I think that's the one that you commonly forget. I would highlight property number 1. Any log of 1. ln of 1, 0. Log base 2 of 1, 0. Common log of 1, 0. Any log of 1, 0. First property, property number 1. And besides that, good things to look at. I would say, remember I said to highlight the transformations of the functions. I do the same thing with logarithms. Just a quick review, maybe using the examples we did, maybe going to homework and saying, how did they ask me to do problems on this again? I don't know what I hit. I hit something. Don't think you need to stress about that too much. Okay, section 3.3. These 3 properties, product, quotient, power, hopefully we're studs on those, but still might want to highlight. How to use them. Know the difference between what it means to expand or condense. You might look over a few examples. Expand and condense, the 2 big words.
What were the properties? What were product?
Product, quotient, and power. Remember, single log of a product, 2 logs being added. Single log of a quotient, 2 logs being subtracted. Single log of an argument raised to a power pops in front. And then the rest, guys, wasn't this a section? Oh, we didn't do tons of examples. Sorry, that was 3-4. We didn't do tons of examples. This one wasn't the really hard one. But didn't you guys still have some struggles on some of these? I had some of these written up, yeah. So just be careful. You might want to review some of those homework problems in your spiral. Not a bad idea. Or in your test review, you're going to have some expanding and condensing, right? Okay. Section 3.4. Ugh. That was all review. No big deal. Where did it get weird? Not really there. Not really there. Didn't it just get weird in the problems? We had to actually put in to undo, right? Like to get rid of ln, put in an e. To undo a log base 3, put in a 3. The one step you guys commonly forget of this one is number 1, is to isolate. When you have an equation, you have to get the exponential or logarithmic piece alone and get everything with x's on one side. Where did it get weird? Kind of started getting weird here. We had to move the 8 first to get rid of the 3 to the. Could you have used a log base 3? Yeah, but what did I end up using? Because I just thought it was easier for us to know the ln's work. I used ln, and what happens to the power? He popped down. We do some distribution, and then we do some moving. But on these ones, kiddos, there are many different ways of writing it. So either, remember this one, it was the get your answer in a decimal and see if the decimal is the same as the book's decimal. They might look totally different, but be the same. Remember that one? Okay. Either these are going to be long answer on the test. So you just give me an answer, and I will have to, the burden's on me to figure out whether or not it's right, okay? So either it's long answer and you just give me an answer and I figure out whether or not it's right, or it's going to be one that you could double check on your calculator, meaning you would solve for it, get an answer, and either you're matching to decimals, or you could get yours as a decimal and get their answers as a decimal and make it match. Does that make sense? Okay, on this one, there were odds in the back of the book that you guys love to check, right? Okay. Did your answers ever look differently than theirs? Probably yes. But they said get it as a decimal, and that way you can compare the decimals and see if they matched. So if tomorrow these harder equation ones are in the multiple choice, you can get yours as a decimal. Plug it in your calculator once you get it. And if there are no decimals in the answers and they're all like written with ln's and logs and stuff, you can get those as decimals and then see which one matches. If it's not easy to match right away, does that make sense? Plug yours in the calculator, and you can always plug the other ones in the calculator. Find the one whose decimal is the same. So that's just one of those problem-solving tips just in case. But otherwise, it's a long answer, and you just box yours and say, hey, here it is. You figure it out. And I'll be like, okay, I can do it. I would maybe star this one. Remember why he was weird? You had to factor him. He was a quadratic. That's one that some of you guys, you didn't like seeing the first time. Number 40, that's a good one to look at. And then otherwise, I think he was pretty straightforward. But there were some tricky ones in homework. I know we went to the boards on that one, okay? So in 3-4, remember, some of those problems got hard. You might need to go back and look at the ones where you had to correct and then find your mistakes. Try not to make them tomorrow. All right, tomorrow. Remember, I said some of these formulas you're not even going to see tomorrow. You won't have to stress about. The Gaussian one you're not going to see. The logistic one you're not going to see, okay? However, growth and decay, you might see one of those. But guys, aren't they really the same equation?
Yeah.
Just growth has a positive, decay has a negative, okay? So one equation. And then I'll give you another hint. You don't have to memorize the n compoundings. Just PERT. How about that? Just PERT?
Yeah.
Okay.
That's good.
Just continuous compounding, A equals P e to the RT. I won't make you memorize the n compoundings, okay? Okay. What else is there? Nope, right? No stress, no stress. Logarithmic. You don't have to memorize him. He just has a logarithm. No big deal, okay? Don't stress. Don't have to memorize him. And then, all the rest, they either give it to you or you're plugging into a formula that you know, right? Okay. There are no problems like number 30 tomorrow with the countries and all the crazy extra stuff. However, I could give you, let's go back, just because I'm a little scared that some of you totally ignored number 30 because he was too scary. Let me do one quick example, okay? What if I wanted you to find let's make it prettier. Let's change it to 33. Okay. This is basically what the whole number 30 was having you practice. 2 points. They tell you what equation to use, and you just have to plug and chug and try to figure out all the unknowns. All right, so what's exponential growth? We started a second ago. And if it's dealing with time, it'd be like bt, but we can just say bx for right now. Okay. What are we going to do with our x's and y's? Plug them in, right? So we have 2 different sets of points, so 2 different equations. Where's the x go? In the x spot. Where's the y go? In the y spot. Where's the x go? In in the x spot. Where's the y go? Got it. Now, what's the struggle with both of these equations? How many things am I missing? Substitution, right? What's going to be the easiest thing to solve for over there? Yeah, A is the easiest thing to solve for. B is kind of stuck right now. So can't we solve for A by dividing 11 by, move them over, e to the, I don't like that. Can I just write it 5 times B? Solve for A by dividing over, and then what do I do with them? Plug them in. See it? Substitution. So then I end up, we're right here, 33 is equal to 11 over e to the 5b times e to the, I don't like that, 7b. Okay. Come on, cool kids. What do I do if there's an e to the 7b over an e to the 5b?
Subtract.
Subtract the exponents whenever I'm dividing. So I have 33 is equal to 11. What's 7b minus 5b? 2b. Divide by 11. How do I undo an e? That cancels. I have 2b equals him. I can divide by 2. Don't I know who b is now?
Yeah.
So b is a check. But who else do I need to finish solving my equation? X, I don't mind. We always have equations with x's. Y's, I don't mind. We always have equations with y's. I have a formula. So all I have to do is say, oh, you know what? Hold on, I know who A is. A is equal to 11 over e to the 5 times, and I plug them in. Now it's a little funny to be 5 halves. We have to kind of move that up. Well, actually, technically, do you want to be super snazzy? Which maybe you don't. If this was a calculator, you'd be like, whatever, plug it in, get decimals, right? But if it wasn't a calculator problem, how could I simplify this dude? I see an e and I see an ln, but there's that 5 over 2 just stuck in there, right?
Combine it and then make it an exponent.
Can I bring him up?
Yeah.
So we have a equals 11 over e to the ln of 3 to the 5 over 2. Is a 5 over 1. What happens to e to ln? No, it's still not pretty. 3 to the 5 halves. I don't know who that is. Do you know who that is? We'd have to go plug it and chugging him into our calculator. But I just wanted to remind you, we can't cancel e and ln until a power goes up, right?
Isn't that 33
Let's see.
instead of 3?
Oh, it might have been. Did I write it wrong? Let me check. Oh, no. It was 33 divided by 11. We had to divide by 11 here first. See? So divide by 11.
Oh, yeah.
There you go. Is that better? Okay. So all of you guys who were like 33, no. Number 30 in homework scared me.